Hi, welcome to Mrs. Park's geometry class. This is chapter 2, section 8, part 2. Alright, so proving angle relations, part 2. And here in the classroom we have Mr. Knighton and Mr. Nagel. If you guys want to say hi, you can say hi for a second.
Nope. I love math. I love
Alright. So congruent angles. The properties of algebra that apply to the congruence of segments and the equality of their measures also hold true for the congruence of angles and the equality of their measures. So property of angle congruence. So just like when we had, if you remember from the previous section, just like we have angle segment SQ is congruent to segment PR. Then the property of segment congruence, this translated into SQ is equal to PR. So just like that, it goes same for angles. When you have measurement angle 1 is congruent to angle 1, it's the same thing. This is called reflective property. Whoops, hold on. And when you have measurement angle 1 is congruent to measurement angle 2, and it's flipped, it's called symmetric property. And when you have measurement 1 is equal to congruent to measurement 2, and measurement 2 is congruent to measurement 3, then you have measurement 1, remember the middle alikes can cancel out, so measurement 1 is congruent to measurement 3, transitive property. So it's all the same that goes for angles when you had the same property for your segments. Right. Symmetric property of congruence. Okay, so angle 1 is congruent to angle B. Then you want to prove that angle B is congruent to angle A. So for this one, we're doing a paragraph proof where a given angle A is congruent with angle B. By the definition of congruent angles, measurement angle A is congruent to measurement angle B. Using the symmetric property of equality, measurement angle B is equal to measurement angle A. And thus, angle B is congruent to angle A by the definition of congruent angles. Okay. So when we use abbreviations, you have an angle and an S in it. That means angles. Okay, so instead of writing out angles, you're going to have an angle sign with an S inside it. Alright, theorems. Congruent supplement theorem and congruent complement theorem. So remember, supplement means 180, complement means 90. So when you have angles supplementary to the same angle or two congruent angles are congruent. So angles supplement to same angle or congruent angles are congruent. So you have measurement angle 1 plus measurement angle 2 is 180. And measurement angle 2 plus measurement angle 3 equals 180. Therefore, angle 1 is equal to angle 3. Complement, same thing, we're just using 90 degrees. Okay. One case of the congruent supplements here. Alright, so we're going to prove that angle 1 is congruent to angle 2. So angle 1 and angle 3 are supplementary. Angle 2 and angle 3 are supplementary. Therefore, angle 1 is equal to, or congruent to angle 2. So, first you start with given. Okay, that's what's given. We're trying to prove this. Alright, so measurement angle 1 plus measurement angle 3 equals 180. Measurement angle 2 and measurement angle 3 equals 180. That's the definition of supplementary angles. So, if this is a 180 and that's 180, then this must equal that. Okay, so we're just substituting. Okay, instead of 180, they're both equal 180, so they must both equal each other. So substitution. Now you have reflective property because you have measurement angle 3 is equal to measurement angle 3. Okay, therefore measurement angle 1 is equal to measurement angle 2. You subtracted these from each other. Subtraction property. And measurement angle 1 is equal to measurement angle 2. And when you put the congruent angles, that's the definition of congruent angles. Okay, moving on. Proofs using congruent complement or supplement theorems. Prove that vertical angles 2 and 4 in the photo at the left are congruent. So what's given is measurement angle 2 and measurement angle 4 are vertical angles. and we want to prove that they are congruent. So here we have a building. The 100-story John Hancock building uses huge X braces in its design. So it has X's here, here, and continues all the way up to 100 stores. These diagonals are connected to the exterior columns, making it possible for strong wind forces to be carried from braces to the exterior columns and back. So all these X's are making up vertical angles. Alright, so we're going to prove that these two angles are congruent. So angle 2 and angle 4 are vertical angles. That was given. In my definition of vertical angles, angle 2 and angle 4 are non-adjacent angles formed by intersecting lines. Okay. Definition of linear pair, angle 2 and 3 form a linear pair, and 3 and 4 form a linear pair. So let's look at the angle again. Okay, 1, 2, 3, 4. So here we have the X, and you have angles 1, 2, 3, 4. They're saying 2 and 3 form a linear pair. 3 and 4 form a linear pair. Definition of linear pair. Angle 2 and angle 3 are supplementary. So 2 and 3 make 180. Angle 3 and 4 are supplementary. They make 180 degrees. Supplement theorem. Therefore, angle 2 is congruent to angle 4. Angles supplement to same angle or congruent angles are congruent. Alright, so I know this may seem a lot to you, but we'll just take one step by one. So here's your turn number 3. In the figure, well, we don't have a figure. Okay. So in the figure, angle ABC and DBC are right angles. Prove that angle ABD is congruent to angle EBC. So we will look for a textbook for this figure here. Okay. And if not, let's get back to this when we come back to school and we'll look in the textbook for it. Alright. So here, vertical angle theorem. So this is another theorem. Okay, the angles that are facing each other are congruent. So angle 2 and 4 are congruent. Angle 1 and 3 are congruent. Alright, so use vertical angles. Prove that BD, ray BD, bisects angle ADC, then angle 2 is congruent to angle 3. Okay. So given is that BD bisects angle ADC, bisect meaning they're equal. So this angle and that angle are congruent. You want to prove that angle 2 is congruent to angle 3. Alright, so the proofs, BD bisects ADC is given. Angle 1 is congruent to angle 2. Definition of angle bisector. Okay, you're cutting in 2. Angle 1 and angle 3 are vertical angles. Definition of vertical angles. So 1 and 3 are vertical. So angle 3 is congruent to angle 1. Vertical angles are congruent. So the 3 and 1, they're equal. Angle 3 is congruent to angle 2 because it's transitive property. Because if it's telling us that angle 1 and 2 are congruent, then angle 1 and 3 must be congruent as well because they're vertical angles. So that was transitive property. And we're going to just flip this. Angle 2 is congruent to angle 3, symmetric property. Alright, so here's your turn number 4. So go ahead, do number 4. Okay, if angle 3 and 4 are vertical angles, let's say this is angle 3 and this is angle 4. Okay, so they're just saying they're vertical angles. That means they're equal. So this and that is equal. Okay, so let me erase it so you can actually see the problem. So the question is, find measurement angle 3. Alright, welcome back. So you guys will remember that this sign here, the symbol, means perpendicular. Okay, that means 90 degrees. Excuse me. So right angle theorems. Perpendicular lines intersect to form 4 right angles. When you have a perpendicular line, 90 degrees that intersect, they're all 90 degrees. All right angles are congruent. If they're 90 degrees, then they're, of course, they're all equal to each other. Perpendicular lines form congruent adjacent angles. So if they're perpendicular, they form 90 degrees and they're touching each other. If two angles are congruent and supplementary, then each angle is a right angle. Okay, they're supplementary and they're congruent, they're the same, that's 90 degrees each. So supplementary means 180, but if there are two angles that are equal, they're divided by 2, that means they're 90 degrees each. If two congruent angles form a linear pair, then they are right angles. Okay, so if two congruent angles, they're two same angles that make one line, that means they're 90 degrees each. Okay, so that is the end of our lesson today. So thanks for watching.